Hi, welcome to another session of network synthesis analysis. In today's class, we are going to see foster form 1 and foster form 2 pertaining to RC networks. In the last class, we have seen about RL networks. Now we are going to see about RC networks. So you can see here foster form 1 for RC network in this form, as well as foster form 2, which has taken the shape of admittance. So we directly go with the first approach, that is Z of S is equal to S plus 1 into S plus 3 divided by S into S plus 2. Now, the given function is having poles and zeros, and if at all we plot them, we are going to get the poles and zeros on negative real axis, which is shown over here. You can see s is equal to 0, a pole is there at the origin, s equal to minus 2, so there is another pole over represented on the negative real axis. Then we have zeros at s equal to minus 1 and minus 3. Also, lowest critical frequency, here it is a pole which is located at s is equal to 0. Now, Foster form 1 for this equation 1 can be determined by identifying the degree of the numerator and the degree of the denominator. Here you can see the degree of the numerator and denominator are both in same. When the degrees are same, then you can directly apply the multiplication and you can go for the synthetic division. So when the synthetic division is done, you can see here we are left over with 2s plus 3 as the remainder, where the quotient is 1. Now, when you take this impedance function, you can write this as 1, which is a quotient, plus remainder 2s plus 3 divided by the s square plus 2s, the divisor. Then identify the first term in the impedance function and the second term in the impedance function. Now the second term in the impedance function can be elaborated with the partial fractions, which is given by equation 3, and that can be determined by a1 and b1 as 3 by 2 and 1 by 2, thereby representing z1 of s, that is the first impedance of the sub function of the main function z of s, given by equation 4. Now the general representation of fossil form here 1, you can see we have z1 z2, and that is obtained here, which is nothing but z of s is equal to z0, which is 1, and z1 of s is nothing but 3 by 2 by s, and z2 here is given by 1 by 2 whole divided by s plus 2. Now with the equation 5, we can get the value of z0, which is nothing but equal to r0, because it's a constant, so it represents the resistance parameter. Z1, which is equal to 3 by 2 by s, represents the capacitor function. So the capacitor we are going to take here quite opposite to the parameter which is in the numerator and denominator of Z1 of s, like this. It is 2 by 3 farad. And Z of RC of parallel combination means this parallel combination can be obtained by the formula Z RC of s, which is nothing but Z2 of s given by 1 by C2 whole divided by s plus 1 by R2 C2. Now with this things, you can easily identify the like terms, that is C2 is equal to 2 farad and R2 equal to 1 by 4 ohms. Now you can substitute in the value of Z2 of S with the given parameters. We are going to get the value here of the impedance function, which is the parallel combination of RC network, as 1 by 4 ohms in parallel with 2 farads. Now combining all these things, you can prepare a table like this, and from this table we can easily get the Foster form 1, which is designed like this. You can see here we have resistor, we have capacitor, then followed by resistor and capacitor in parallel combination, and the values are given like this. Hence it's a Foster form representation of RC function. What about Foster form 2? Now take the impedance function and take the y of s, that the admittance of s, that is the inverse of this z of s value. So equation 6 is framed, and again we are identifying whether the residues are negative or not. So that can be done with the help of partial fractions, and here you can see we got the residues. So when we have the residues as negative, then we can change the equation 6 as y of s by s. Hence the admittance is changed to y of s by s. Therefore, again we are finding out the partial fraction values of y of s by s, which is termed as a1 and b1, obtained here, obtained to be 1 by 2 and 1 by 2 respectively. Substitute the value, we got the equation 8, and then y of s is framed as 1 by 2s by s plus 1 plus 1 by 2s by s plus 3, equation 9. Now we can see admittance form takes in the parallel combination of series circuit. So here Foster form 2 represents the admittance, which is taken as the admittance parallel combination, and inside the admittance you have the series combination of resistor and capacitor. So let us take these values as y1 of s and y2 of s functions. Now y1 of s is given by uh, 1 by 2 s whole divided by s plus 2 as given in the problem. Obtained in the problem. With this, the like terms can be framed and R1 and C1 are framed. Likewise, you can get for the values of R2 and C2. And finally, we can frame the Foster form 2 original circuit, which is nothing but Y1 of S and Y2 of S, which is having the series combination of resistor and capacitor. So substituting the values and hence the Foster form 2 representation of RC function. So this is how you need to solve the impedance function given in RC form. Let us go with another example. You can see here z of s is given by s plus 1 into s plus 3 whole divided by s into s plus 2 and s plus 4. Now, if the pole zero plot is given here, we'll just plot this pole and zeros values. We can see we have 0 at origin, pole at origin, minus 2 is another pole, and minus 4 is another pole, whereas the zeros given by minus 1 and minus 3. So identifying the numerator and denominator degree. Now you can see the numerator degree in equation 1 is less than the denominator degree. Then what is the rule to be followed? Just you take the partial fractions directly. So we have taken the partial fractions of equation 1 as equation 2 and try to obtain the ABC values. So once the ABC values are obtained, reframing the equation 2, we get the equation 3. And now z of s is directly obtained as 3 by 8s plus 1 by 4 by s plus 2 plus 3 by 8 by s plus 4. Now framing the sub impedance values of the equation 3 and resolving z1 of s and z2 of s. So z1 of s is given by 1 by c1 by s plus 1 by ri ci. I represents the different values which are arranged in series fashion. So z1 of s is obtained to be 1 by 4 by s plus 2. Thereby c1 r1 values we got here as 4 farads and 1 by 8 ohms. This is not farads, this is ohms respectively. And similarly, z2 can be obtained as 3 by 8 by s plus 4. Therefore c2 is obtained by as 8 by 3 farads and r2 is obtained by 3 by 32 ohms. Now framing the equations in tabular column for easy understanding like this, and substituting the values of z0 of s, z1 of s and z2 of s with c1 r1, c2 r2, we can get the Foster form of RC network for the given function, and which is obtained to be in this form. On the another basis, we can go with the Foster form 2. Just you take the inverse of this equation 1, identify the numerator degree and denominator degree, but here the numerator degree is greater than the denominator degree. So we'll take y of s by s because residues will be negative. So y of s by s in it is in the synthetic division form. So we'll apply the synthetic division and we'll obtain the value of y of s by s, which is obtained to be 1 plus 2s plus 5 by this s square plus 4s plus 3. Now reframing this with another partial fraction values, we can get the values of subfunction y1 of s as 3 by 2 and 1 by 2. After getting the values of a2, b2, just substitute in the y1 of s and thereby substituting the value of y of s by s. So y of s by s is obtained to be 1 plus 3 by 2 by s plus 1 plus 1 by 2 s plus 3. Now what we do, we are going to take this y of s in equation 7 form, and again we'll apply the y of RC admittance form, which is given by the formula 1 by Ri by s plus 1 by Ri Ci. This whole function multiplied with s. Now y1 of s can be obtained by 3 by 2 s divided by s plus 1 with the values of r1 as 2 by 3 ohms, c1 value is 3 by 2 farad, whereas r2 value is obtained to be 2 ohms and c2 is obtained to be 1 by 6 farad. Now with these values, you just make sure that the values are taken in a proper way of r1, r2, r1 and c1 and c2 as well as c0, and this Foster form 2 is represented by this values which is shown in this particular figure. That's all for this class. I hope you like this video. Please share among your friends, subscribe to this channel and press the bell icon for